In this video, let's take a look at how to make a foldable solar charger. Now let's take a look at the parts. First, you'll need 3 solar panels. I've used 3 solar panels with the size of 150 by 130 millimeters. Then, you'll need a USB DC to DC step-up converter that steps up from 3 volts to 5 volts. Then, you'll need wires. I've gone for 30 AWG wires. AWG stands for American Wire Gauge. So the number 30 corresponds to the diameter of the wire and also the resistance. So as the number gets higher, the diameter gets smaller and the resistance gets higher in the wires. And then you'll need the 3D printed housing, which I got from Thingiverse. I'll leave a link in the description below. The housing can be printed with either PLA or PETG. I've gone with black PLA here because it would match the color of the solar panels. Before I printed the design, I decided to make a few changes, including adding 2 stands that could be used to set up the charger at a 45-degree angle so it could point at the sun, add 2 holders for each stand on the model itself, and also to increase the size of the USB converter holder, because it was too small for my USB converter. Then, I also used some vinyl sheet roll to cover the exposed backside of each panel. Then, you'll also need 4 bolts and nuts of the M2 variant. Then, you'll need a multimeter to check that all your circuits are working correctly. Finally, you'll need a soldering iron, a holder, and some solder to connect up your wires with your panels. Now, let's test the solar panels. First, set up the panel you want to test, facing a light with one of the stands from the design. Then, use the multimeter to check that the voltage from the panel is approximately 5 volts. Now, let's mount the solar panels. To mount the solar panel, just slide it into the holder, and make sure that all the solar panels are oriented in the same direction when you've done so. To wire one panel with the next, you're going to need about 30 centimeters of red and black wire. Then, you're going to solder the red wire to the positive terminal and the black wire to the negative terminal of the first panel. Then, you're going to solder the red wire to the positive terminal and the black wire to the negative terminal of the second panel as well. Then, secure the wires onto the panels with tape. Repeat this process to solder all the panels together. Then, pass 2 more wires through the slot for the USB converter, and then make sure that they don't come off the USB converter when you tug on them lightly, so that makes it easier to solder the wires onto the USB converter. Then, solder the wires from the USB converter onto the third panel. The circuit we have here is a parallel circuit where all the positives are wired together and all the negatives are wired together. In a parallel circuit, the voltage drop does not increase, whereas the amperage increases across all 3 panels. Since each panel is 5 volts at 0.5 amps, in total we're going to have 5 volts with 1.5 amps, rather than in a series circuit where we would have 15 volts at 0.5 amps, which would be too much for a phone charger. Finally, solder the wires onto the USB converter, making sure that the red wires on the positive and black wires on the negative. Then, use the 4 bolts and nuts to screw each fixture together, but make sure it's not too tight, because the fixtures still need to be able to rotate, which is the whole point of a foldable charger. Then, cut out some of the vinyl wrap to cover the back of each panel. Finally, use your hot glue gun to glue your USB converter into the slot for it, and then use the lid to cover it up. Finally, let's test the charger. Here, I have the USB charger for my smartwatch. I'm gonna plug it in under my workshop lights to see whether it charges correctly. And there we go, we can see that the watch is charging now. Thanks for watching. Hopefully you guys can make your own versions of this project and put it to good use.